In nature, when the larvae looked for a place to settle, many times they choose a dead coral, which means those substrates are rich on calcium carbonate. Calcium carbonate is the main component of the skeleton of corals, of the hard tissue of corals. And they choose calcium carbonate.
But at the same time, the things that are interesting for the larvae to land on are also interesting and nice for other organisms. And so there's a constant competition between the coral and things like algae that can take over the space and choke out the larvae or the juvenile corals before they're big enough to really establish themselves on the surface.
We are trying to improve that initial stage of the life of a coral. We are trying to develop materials that promote the settlement of coral larvae and also substrates that help the coral grow healthier and faster.
The idea is to try to help the corals from the point of view of the material science, changing different compositions, adding some specific ions or some specific additives that will improve the habitat for the corals and also attract them when they are in the larvae stage.
The end goal is to regenerate and restore coral reefs.
We are not looking for substrates that are very exotic and difficult to make and very expensive. We are looking for substrates that are sustainable, that can be used everywhere and that they are cheap. So the main components of our substrates are calcium carbonate, and this is inspired by nature, right? Because that's the choice of the larvae when they settle in the ocean. But making a substrate only of calcium carbonate is very weak. So essentially it disintegrates when we have it in water for a long time. And so these substrates have a component which is calcium silicate. When you mix calcium silicate and water, it hydrates, and this provides strength. And so it's the combination of calcium silicate and calcium carbonate. And then, of course, other substances that we add in very, very small amounts, which are the cues for the larvae settlement.
So you're incorporating some molecules that have a certain property that you are interested in, and you have a material that you have to fabricate. Sometimes when you incorporate those molecules or other materials into your base material, they change. You might not know how they change, and you also don't know how they're released. Are they released really fast? Are they released really slowly? Can they be released? Are they trapped in the material and can't be released at all? You know this molecule is good, you know the larvae like this material pretty well, and you want to put those two things together, but there are challenges associated with simply combining those materials, let alone having the larvae interact with the material.